So we have a scenario here where at the concession stand, hamburgers cost $4 a piece and pork chops cost $6 a piece. So if you had only $48 in your wallet to spend, what would be the possible combinations of numbers of hamburgers and number of pork chops that you could purchase? So in a scenario like this, really you're counting two different quantities, two different unknowns. So if we define some variables here and we suppose that X is going to be the number of hamburgers that you could purchase with your available funds, and then Y is going to be the number of pork chops you could purchase with your available funds. We know that if you have $48 to spend and you're going to spend exactly $48, then by taking the number of hamburgers times its cost plus the number of pork chops times its cost, that should end up equaling 48 very nicely right there. So that gives you an equation that models what's going on right here. And so if X here is going to be the number of hamburgers that we purchased, and then Y right here is going to be the number of pork chops that we could purchase. If we wanted to graph this relationship, we would want to probably do so by solving for Y. So we would have 6y equals negative 4x plus 48, of course, by subtracting 4x on both sides. And then by dividing by 6, you get negative 4/6, which reduces to negative 2/3 x. And 48 divided by 6 ends up giving you 8. And so 1, 2, 3, 4, 5, 6, 7, 8. And then a slope of negative 2/3 is going to go like this. And so this would give you kind of the graph of the relationship. And each of these points are going to make sense overall because, for example, this ordered pair right here of 0, 8 is going to tell you that you have 0 hamburgers and 8 pork chops, which if you did 0 times $4 for a hamburger plus 8 times $6 for a pork chop, it does total out to be 48. And the same is true for any of these other order pairs. So like down here, that's going to be, I believe, 9, 2. So if you did 9 hamburgers and 2 pork chops, lo and behold, 9 times 4 plus 2 times 6 does end up equaling $48. So all of that is true about the equation we're seeing there. So this equation that you actually see here that we use to write the model is actually in a form that we call standard form of a linear equation. And what standard form of a linear equation is going to be is it's going to be a number times x plus a number times y equals a number. So really, it's just like the x and the y are like all on the same side as one another. So some things you want to understand about this is that a, b, and c are always needing to be integers actually, so we don't want any fractions or decimals, because remember that integers are like -2, -1, 0, 1, 2, so no decimals, no fractions or anything like that. And we really just want the x and y to kind of be on the same side. So some examples of things that would be in standard form would be like if you had 4x minus 9y equals -21. Because the coefficients of x's and y's are integers, the -21, that constant is an integer, and x and y are the same side as each other. Also, if you had like, I don't know, like y equals 5, that's totally in standard form too, because you could treat it as like, oh, I have a 0 in front of x then, right, and a 1 in front of y, so that would also be in standard form and just kind of be a special sort of case. Same thing if you had like an x alone, right, if x was equal to -8, that would also be in standard form. Some non-examples would be like if you had y equals -7x plus 10. Although everything there is integers, x and y are not on the same side as each other, so that's something not in standard form. Also, if you had like 1/2 x minus y equals 6, it's almost in standard form, but because you have a fraction right there, you want to make sure you have an integer, and there's a way we can fix that, which we'll get to in just a little bit. So there's a couple ways that we could actually go about graphing lines in standard form. So one way we could do this is really just go in slope-intercept form, which is just solve the equation for y. So if I take this equation, 3x plus 4y equals 24, if you subtract 3x from both sides first of all, you get this equivalent equation, and then divide both sides by 4 to isolate the y, you end up getting -3/4 x plus 6 is equal to y. And then based on what we were doing just previously, then you know, okay, hey, my y-intercept's at 6 and my slope is going to be -3/4. So to graph this line, I can start at 6 for the y-intercept and then do a rise of -3 and a run of 4. And then you'll be able to get a nice, good, accurate sketch of the graph of your line accordingly. And then if you want to find the x-intercept, it does turn out it had a nice integer coordinate right there of 0, 8. Now, alternatively, one nice thing about standard form is that it's really nice to be able to find your intercepts. So right here, if we don't actually solve it for y, we will be able to find the intercepts because we know that for any x-intercept, its y-coordinate is 0. So if you substitute in a 0 in for y into the equation, so like this, then you can actually solve for x. And what you'll get for x is actually 8, which we know is the x-intercept because we have the same example side by side right here. And then, I guess I wrote it backwards, though, when I was doing the slope-intercept form right there. That should be 8, 0. All right, and then if you're finding a y-intercept, we always know that a y-intercept, its x-coordinate is always going to be 0. So if you substitute a 0 in for x, and then you solve the equation then for y, here we get that y is going to be 6. So there you get the y-intercept would be 6. And so that's actually a nice way to be able to graph sometimes when you're dealing with like standard form, is if you just find the intercept, so an x-intercept of 8 and then a y-intercept of 6, we know that any 2 points are going to uniquely define a line within the coordinate plane, and then you get a nice little sketch of your graph right there. For these examples right here, you could simply graph these lines just by solving for y, but I specifically just want to, for reinforcement, to do the following. I want to use intercepts to graph the line. So since they're both in standard form, it's really nice and convenient to be able to find the intercepts. So if you're finding an x-intercept, every x-intercept has a y-coordinate of 0. So you can just substitute in a 0 for y to be able to solve for the x-intercept, which really just gives you 5x equals negative 10 in this example. So it gives you x equals negative 2. So you know that's where the x-intercept would be. And then because any y-intercept for a particular line is going to have a 0 for its x-coordinate, you can substitute 0 in for x and then solve for y. So you end up getting negative y equals negative 10, so y equals 10. So then you know that indeed the y-intercept would be at 10. So then if you plot the x-intercept right there and you plot the y-intercept right there, you get 2 points, and then that gives you a pretty decent sketch of the line. And of course this is going to make sense because if you did take this equation and solve it for y, you would actually get the equation that y equals 5x plus 10, which does tell you that when it's in y equals mx plus b form, that the slope would be a positive 5, which is indeed happening because it's up 5 over 1, up 5 over 1, and then also you can see that the y-intercept there is 10. So one more example where we can use intercepts to be able to graph something is in this equation right here. So if you're going to find the x-intercept of this line, you can substitute in as 0 for the other letter, which is y. So then negative 9x plus 6 times 0 will equal negative 12, really just giving you negative 9x equals negative 12. So if you divide by negative 9, you end up getting that x equals 4/3 positive when you reduce that. And then you also get the y-intercept to be a 0 for x, so negative 9 times 0 plus 6 times y equals negative 12. So really just 6y equals negative 12, or y is going to equal negative 2. And so you get those kind of nice pairs. I know the x-intercept isn't perfect, but 4/3 would be about right there. And then for the y-intercept, negative 2 is going to be right there. So it gives you kind of a somewhat decent sketch of your line. That might be one where you might want to solve for y, of course, to get y equals mx plus b and get you a little bit more of the graph there.